Cravo is the originator and the world's leading manufacturer of retractable roof greenhouses and shadehouses. With over 30 years of experience and installation on 5 continents, Cravo retractable roof houses have been installed in all climates, the tropics, deserts, and locations with hail and snow. Cravo retractable roof houses have been used to grow young plants, food crops, seafood, trees for reforestation, ornamental trees, shrubs, cut flowers, and potted flowers. They have also been used to create better environments for people in shopping environments like retail garden centers. And now, Cravo retractable roofs are also being used in the amusement industry to create optimum conditions by being able to quickly protect guests from sudden rain, heat, or cold. Cravo has created different models of retractable roof houses and coverings to suit your crop, climate, and budget. For all models, the retractable roof coverings are made using reinforced polyethylene that is suspended from specially designed hooks which slide on stainless steel wires. The roof coverings are either clear or white and can be supplied as water porous or non-porous. A clear roof is used where outside temperatures are too cold for an extended period of time, whereas white roofs tend to be used more in tropical locations where reducing temperatures is usually more important than increasing temperatures. The Cravo roof coverings have on average a useful life of 8 to 12 years. In fact, not even one roof covering has ever blown off due to wind, and this includes the 7 hurricanes that have hit Cravo houses over the years. There are 2 basic designs of retractable roof houses: the flat roof and the peak roof. You are now looking at a 10-hectare retractable flat roof, where all 10 hectares are being opened by 12 motors. The flat roof is the lowest cost retractable roof and is ideal for protecting large fields of crops since one motor can close almost 1 hectare of roof in only 6 minutes. It allows farmers to cover large fields, and the wide spans between the posts and tall head clearance allows farmers to use the same equipment and planting techniques that they currently use in the open field. The flat roof is normally oriented with the post lines running north to south so that the shadows from the retracted roof or direct sunlight bands are moving across the crops as the sun moves from east to west throughout the day. The flat roof is designed to help protect crops from excessive cold, heat, wind, and hail. There are different degrees of rain protection available when using a flat roof depending on the roof covering chosen. For crops that are rain tolerant but can be damaged from the impact of a hard rain, a water porous roof covering like RCO2 white uncoated can be used. For cases where it is desirable to keep the majority of the plants dry, a woven and coated covering like RCO2 clear or white can be used. The coating prevents rain from penetrating the roof, but the roof must have drainage slits cut in the roof to prevent water buildup on the roof. The drainage slits are cut on a 45 cm by 67 cm grid, which ensures adequate drainage, but yet keeps 98% of the crops dry. For crops that must be protected from rain and or snow, A peaked or A-frame roof profile is required. On a peaked roof, one motor can close almost 5,000 square meters in only 2.5 minutes. The roof covering travels from truss to truss, and the moving edge of the roof overlaps a stationary edge to create a seal against air and water leakage. The roof covering is a coated reinforced polyethylene like RCO2 clear or RCO2 white. When it rains, the water drains down the roof covering and then enters the gutter through slits that are factory installed in the roof covering. The peaked roofs should be oriented such that the post lines are oriented generally east to west to ensure that the shadows from the retracted roofs or direct sunlight bands from when the roof is closed 85% move across the plants as the sun moves throughout the day. It is definitely not recommended to have the post lines on the peaked roof houses oriented perfectly north-south, since crops will be subject to sunburn when the roof is closed 85% for cooling on hot days. The peaked roof houses come in three models: the X-frame, the A-frame rafter, and the A-frame. Each model protects crops from cold, heat, wind, rain, and hail, but the three models have different snow and wind load capacities and costs. For all models, if winds are forecasted to exceed the design load, then the roof and walls can be retracted to protect the structure and covering. The X-frame house is the lowest cost retractable roof house, which protects crops from rain. It is available in standard widths of 8 meters and 9.6 meters. The X-frame house utilizes rods and cables to form the trusses and has exterior cable bracing on all four walls. It can be supplied with gutters, or the rain can drain onto roadways in the center of each house. This house is designed for climates where snow or hail is less than 5 kilos per square meter and wind speeds are less than 110 kilometers per hour. If wind speeds are forecast to exceed 110, the roof and walls should be retracted. This house is designed so that it can be installed on gently rolling fields and can support the weight of a crop like tomatoes. The X-frame house is ideal for covering soft fruit like berries, vegetable crops like tomatoes, fruit trees, or covering outdoor growing areas of annuals or perennials. For applications where exterior cable braces cannot be used or higher wind load is required, the A-frame rafter house provides a medium-cost solution. This design is 14.63 meters between gutters and has a post under the peak and the gutter. And the house can be designed for wind speeds up to 177 kilometers per hour with the roof and walls closed. For locations where extreme wind loads occur, or where there are heavy snow loads, the A-frame house is required. The A-frame house is available in a variety of standard house widths and gutter heights. However, it can be custom designed to suit customer-specific sizes and local building codes. The A-frame house has been designed for wind speeds up to 225 kilometers per hour and snow loads up to 340 kilos per square meter. To increase summer cooling and/or winter heat retention, a secondary retractable roof can be installed inside the A-frame or A-frame rafter houses. This curtain system is normally oriented to travel opposite that of the roof. This unique design offers the benefit in the summer whereby the roof and curtain system can be closed part-way to allow for almost 50% ventilation without plants being exposed to direct sunlight. In the winter, the secondary roof acts as a thermal barrier to help improve energy efficiency. To maximize control over the growing environment, the sidewalls are also typically retractable to allow crops to be exposed to wind to help with cooling and pollination. But yet the walls can be closed in minutes to help protect crops from excessive wind or cold. Stationary insect screen can also be added to provide insect exclusion while still allowing ventilation through the walls. To help growers make a smooth transition from the open field or a conventional greenhouse to a retractable roof, Cravo has documented the impacts of the retractable roof on the growing environments and the resulting changes in plant growth and development. This research and documentation has occurred over the last 10 years and has culminated in the creation of the retractable roof production system. This science-based production system helps growers take full advantage of the retractable roof by utilizing the advantages of the natural outdoors as well as that of a greenhouse and shade house environment to maximize crop yield, quality, and timing. The benefits of this production system are covered in the video titled Introduction to the Retractable Roof Production System. With 30 years of experience and sales offices in Canada, Mexico, Spain, and Turkey, Cravo is well positioned to help growers worldwide produce crops more profitably and sustainably while coping with the erratic changes in global weather patterns.